Alright, for this one, I asked you to do all the license plates with 2 letters followed by 6 digits. The easiest way to do this is to set it up like this, and we have 2 letters. Each letter can be repeated. There are 26 letters in the alphabet. There are 26 that go in the first spot, 26 that go in the second spot, and then there are 10 digits. And since things cannot repeat, left off a couple there. Since things can repeat, just multiply all those together and you get this number here, 676, and 1, 2, 3, 4, 5, 6 zeros there. So that is your answer. Okay? Go ahead and move. Alright, to rearrange the letters in the word pizza, there are 5 letters. 1, 2, 3, 4, 5. So it's 5 factorial. And when you have things repeat, if this word didn't have any repetition, that would be your answer. But since this word has 2 z's that repeat, you're going to divide by 2 factorial. Now, if the z's repeated 3 times, you'd have 3 factorial. If you had an extra letter here that repeated, you would just multiply by that repetition. But you get 120 for 5 factorial over 2 for 2 factorial, which gets you 60 for your answer. Okay? So, go ahead and move. Alright, you're trying to figure out all the combinations of picture frames you could buy. All you do in this case is multiply the 3 types together. You have 44 colors times 3 types times 6 different matte board colors. Type that in, you get 792. Okay. Alright, for number 9, the biggest thing you have to look for is, does the order matter or does it not matter? Okay, I think some of y'all got that backwards when you were doing this. 17 softball players need to choose 3 players to refill the water cooler. For that one, order doesn't matter. They don't really give you a specification as to what order they're filling it up in or anything like that. So for this one, 17 and then combination 3. Okay? Order does not matter. When you type that into your calculator, you wind up getting 680. Now for number 11, if you want to do this one, it says you have 10 students and you want to elect the president, vice president, secretary, and treasurer. This is the case where the order does matter. You've got 10 students to choose from. The order matters, so it's a permutation. And you're picking 4 spots, president, vice president, secretary, and treasurer. Type that into your calculator and you will get your answer. Okay, so those are the 2 types you could potentially see. Kind of like the deck of cards, you got 20 players, 12 of which are boys. So how many are girls? 8. Okay, 8 are girls. So you want a 5-person team, and in that 5-person team, 3 of them have to be girls. Well, there's only 8 girls to choose from, and you want to choose 3. It's kind of like the deck of cards. If you want to pick 5 hearts in your deck of 5, there's only 13 hearts to choose from. Here, there's only 8 girls to choose 3 from. Okay, that doesn't give you your 5-person team, though. You still have to take care of the other 2 people on the team, which are going to be boys, and there are 12 boys to choose from. Okay, so type that into your calculator. I've already done that. 8 choose 3 gets you 56. 12 choose 2 gets you 66. Multiply those 2 ways together, and you get 3,696 ways. When you're dealt a 5-card hand, you got to pay attention to the group you're picking from. Like I said before, there are 13 hearts in the deck, and you only want 3. So that's 13 choose 3. And then you multiply it to the amount of ways because you want to take care of your 5-card hand. Okay, that's why you multiply these. The other 2 cards have to be diamonds, and there are 13 diamonds in the deck. You want to choose 2. So type that into the calculator, 13 choose 3, 13 choose 2, multiply those 2 numbers together, and you get 22,308. When you see the words at least or at most, you know you're going to be adding certain combinations of things together. Okay, so there are 4 kings in the deck. You want at least 2 in your hand at all times. Okay, well, let's deal with just 2 kings at first. There are 4 kings in the deck. I want 2 in my hand. Well, I need to finish my 5-card hand, so I need to multiply it by how many ways I can have the other 3 cards that are not kings. Well, there are 48 cards that are not kings. All you got to do is take the 52 cards in the deck, subtract the 4 kings away, and you get 48. And you're choosing 3 from that stack. That is when you have exactly 2 kings. Okay? Then you want to add it to the possibility where you could have more than 2 kings. The least amount you can have is 2. You could have 3 kings in the deck. which means that the other 2 cards come from that stack of 48. That's when you have 3 kings. And then last but not least, you could have all 4 kings in your hand at once. You can't go higher than that. You can't choose 5 kings from a group of 4. It doesn't work. So 4 choose 4 times the other 1 card can come from the stack of 48. Okay? When you put that into your calculator, I think you can do that once you get it set up, is 108,336. Okay? All right, to find these things, go to your stat. You should be comfortable going to the list and editing things. Make sure your numbers are correct. This is the biggest mistake on the test, is that people either miss a number or they type in the number wrong. So go back and double, triple check your work on this, because these are easy points. Once you get it typed into your list, hit stat, go over to calculate, 1 variable statistics, hit calculate, and the list of things that shows up, you just have to be able to work through it and figure out what you need. The X bar is your mean. The mean is 24. The little circle, the line on top, is your deviation. That's 12.829. And then you got to scroll down a little bit to get the rest of the information you need. Median is 21. That comes from right here. Now the other 2 things you got to kind of find on your own, but the range is your max minus your min. So 54 minus 12 is 42. The mode is what number occurs the most often, and that is 21. Alright, to find the probability that you're going to pick an X value that's in between these 2 deviations. This is 1 deviation below, 3 deviations above. So you need to make sure you can draw your chart, okay, which you need to have memorized for tomorrow. It's the only thing you have to have memorized. These are the 3 big numbers. 68% fall between these 2 deviations, which makes this a 34 and that a 34. 95% fall between the 2 deviations, so you do 95 minus 68 divided by 2, and it gives you 13.5, 13.5. And then 99.7 minus 95 divided by 2 gets you 2.35. And then 100% minus 99.7 divided by 2 is 0.15. Okay, you have to have that. If you don't have that, this question is going to be almost impossible to answer. Okay, so you want to find the probabilities you're going to be in between 1 below, which is right here at this pen, and 3 above, which is right here. All you're going to do is count all the percentages in between. 34 plus 34 plus 13.5 plus 2.35. Type that in your calculator, it gets you 83.85%. Okay? If I asked you for percent, that would be fine. Okay, that would be your answer. But I wanted it in probability. So all you do is move the decimal place to the left 2 units or divide by 100. That's 0.8385. And by the way, you will never have a probability bigger than 1. Okay, and so if you're getting 1 point something, or if you're getting 12 point something, that's probably a percent. Make sure it's in probability form. Okay. All right, for this one, same thing. Once you have your chart drawn, look at it, find the 1 deviation below, which is what this is, and you want to find the values of what's less than that. So all of these 3 percentages here, what you're adding together. When you add 13.5 plus 2.35 plus 0.15, you get 16%. That is a probability, is 0.16. As for the percentage that falls in the shaded region, this is just like the question that we did earlier. You look at the chart that you have drawn out. The shaded parts was this part, that part, and the 2.35. So you do 13.5 plus 13.5 plus 2.35. That gets you 29.35%. So that is your answer.